Okay, these objectives 8 and 9. 8 is called verify solutions for given equations. So we're just going to be solving equations and solve for an x and solve for y and then verify that those are correct answers. So sometimes you'll be solving and actually getting the variable. Other times they'll say, is this the solution to the equation? Okay, so which would be easier for you just to plug into the equation and use your order of operations to see if it's a solution to the equation. So you can make a choice. You could solve it, see if your answer is the answer they have, then it would be a yes, or plug it in and do your order of operations. Okay, some people avoid it, like some of the answers are fractions, and they're like, yeah, I don't want to work with fractions, so I'm just going to solve it versus plugging in a fraction and forgetting how to work with fractions. Okay, so it's just kind of a choice. Okay, and then the other one is solving linear equations. So linear equations would mean like y equals x plus b, so it has y in it and x in it. Okay, there's multiple ways to solve those. Okay, so the very first one, and I'm only doing 4, so this is fairly short. So I feel like you know how to do these. Obviously, this is a review.
I don't know.
Well, there's always that one.
So one person.
Yeah.
Well, I actually do know how to do this.
Okay, so problem number 36, it's 5x minus 7 equals a negative 6. Okay, so in solving equations, we actually go opposite of order of operations. We do the adding and subtracting first, which in order of operations is the last, but we do it first when we solve equations, and then the multiply and divide is always last, so it kind of goes backwards. Okay, so our first step would be to what? Add 7. Okay, and what we do to one side, which a lot of you do this in your head, I'm just making sure for those that don't, they know how we're getting there. What I do to one side, I'm going to do to the other side. Okay, so the 5x we haven't touched yet. This gives me 0 because that's the whole goal, is to get rid of it, to move it to the other side. Okay, and then a negative 6, positive 7 is going to be a positive 1. Good to there? Okay, so last step is going to be what? Divide by 5. Okay, so just keep it like this. Don't put it into your calculator and go 1 divided by 5. Like that is an answer. That's 1/5. Okay, you good? Okay, so that's one way. The other option is they're going to say is 1/5. Okay, they're going to ask you, is 1/5 a solution to this equation? So if you don't want to solve it or don't know how to solve it by plugging it in, you could do it this way. Otherwise, you plug it in. So if I plugged it in and did it that way, you're writing this. So you would have 5, and then this means multiplication, right? So we're plugging in the value. This is what we just took a test on. Okay, plugging in the value for x, which is 1/5. Okay, and then writing the rest of my equation. And what you're trying to find out is if the left side of the equation matches the right side of the equation. And if it does, then yes, that's a solution to the equation.
Wait,
Okay?
do we have to on these notes we have to include?
You're going to put this so that you can choose which way, because sometimes it'll be one way, other times you're actually plugging it. Okay, so that you have both. Okay. All right, so if I were doing order of operations in this, I would do the multiplication first. Right now it's opposite of what we just did. Okay, what's going to happen with 5 times 1/5? Right, because they cross cancel, right? Because really this is that. Okay, so we cross cancel that. All of this becomes 1. So now I have 1 minus 7. Does that equal a negative 6?
Yes.
Yes, because 1 minus 7 would be a negative 6. And the left side equals the right side. So yes, that's a solution to the equation. Okay, so sometimes you're solving. Other times they're going to say, is this a number that works for this equation? And you plug it in, and then you answer yes or no. Good? Okay, so you're not writing this. I'm just showing you this is the way it's showed on the worksheet so that you see how it's going to be written. Don't write this.
Oh, they
No, you
No,
write.
I already wrote all this.
You wrote that. Are you still writing that?
No.
You're good. Okay. So this is actually the way it showed on the worksheet. You're not writing this. Okay. So it says, is 1/5 the solution of the equation? So again, you can choose to plug it in like we did the second way. Okay. Or you just solve the equation and see if your answer winds up being that. Okay. You can choose whatever method you want to use. That makes sense. Okay. All right. Next one.
Oh my goodness, this was tricky. X equals Y.
Okay, so it reads as 2x minus 4y equals a negative 18, and 5x plus 5y equals 0. Okay, so the way we've done this, and you guys did this last year, and I know you did it the year before, you can do substitution or elimination. That is 2 ways to solve this, okay? So to do this one, I would probably do elimination and not substitution. Substitution means you have a variable by itself, like x equals this, and then you plug it in, okay? This one doesn't have that, so I do elimination. So our goal is to eliminate either the x or the y, because you have to solve for both, okay? And you just look at them and say, okay, which one's going to be easier for me to change? And one needs to be a positive, one needs to be a negative. So if I chose the x's, I'm going to do the y's, but if I chose the x's, I would need one of them to be negative, okay? And both of those numbers would have to be able to go into a number. So what can 2 and 5 go into? 10. So to make this 10, I would have to multiply that whole equation by what? 5. And then this one by -2. So one of them needs to be negative. Okay, we're going to do the y's just because one's positive, one's negative. Okay, but when you go to do it, it doesn't matter. Okay, so I'm going to choose to get rid of the y's. So what can 5 and 4 go into? 1. Okay, so I put parentheses around my first one, and I want my 4 to become a 20. So that means I would have to multiply it by 5. And you have to do it to everything. Okay? It's not just this part. It's the whole equation has to change. You're making everything increase by 5. Okay? So I'm going to go ahead and do this. I've got 10x minus 20y equals negative 90. Okay, what do I need to multiply this one by in a second thing? 4, because I need this to be 20, right? So everything has to be multiplied by 4. Okay, so 4 times 5 is going to be 20x. 4 times 5 again is going to be a positive 21, and anything times 0 is going to be 0. Okay, so now what we're looking at is like an equation where we're combining like terms, okay, to write where we're at. Okay, so I have a positive 10 and a positive 20, so that's going to give me a positive 30x. What happened to my y's? Cancel out. That's why they call it elimination. Okay, because it eliminated it. Okay, and then here we still have a negative 90. So our last step would be divide by 30. So x would be what? Negative 3. Okay, so I have one of my solutions. Okay, then at this point now we need to solve for y. So you just pick one of the equations that you want to plug back into. Just because you don't want to work with big numbers, I wouldn't plug it back into here because these are bigger numbers. I would just pick one of either that one or that one, the originals. Okay, I picked this one just because it was a smaller number. Okay, it doesn't matter. It has to work in both equations, so it wouldn't matter which one you chose. Okay, so I'm plugging it back into this one. So I'm just going to write it so that you know what we did with this number. So 2x minus 4y equals a negative 18, and I'm plugging in and replacing my x with a negative 3. Okay, so now it's 2 times a negative 3 minus 4y equals a negative 18. I replaced it because now we're just solving for the other variable. Okay, so this would be negative 6. Solving for y, I would do what that. Add 6 to the other side. Okay, so I have a negative 4y equals a negative 12. So then divide by a negative 4. So my y would be 3. Okay, so to know whether or not I did this right, especially when it comes time to a test, okay, it has to work in both equations. Okay, and the reason why I'm bringing this up because I'm going to show you, besides you solving, sometimes they're going to say your answer is negative 3 or 3, or they might say your answer is 3 and negative 3, like they switched it to check it. It has to be able to work in both equations. Well, we know it worked in that one because that was the equation that we just used. So I'm going to check this one. So remember, the left side should equal the right side. So if I plug in my x value, 5 times a negative 3 would be a negative 15. 5 times 3 would be 15, and a negative 15 and a positive 15 gives me 0. So I know I did it right, and the solution to the equation is a negative 3 and a positive 3. Okay? The way they'll have it written is like coordinates. Your x is first, and your y is second. You don't have to write it that way. It's just the way it might appear on some of your worksheets. Okay, we good? Kind of remember that from the last 2 years? Okay. So, this is the way, you're not writing this is the way this one appeared. Does a negative 3, 3 satisfy the following system? So if you plugged in x here and the y here, if it equals a negative 18, it's true for that one, but it might not be true for the second one. So you have to check both of them on there. It's not just one equation, okay? All right.
So that's just,
Did plug it in and check it, yeah.
well, I mean, if it's true for one of them,
Then it's not a solution to the equation because it has to work for both of them.
then.
Yeah. Oh, and I'm glad you brought this up. Hold on a second. So where this is coming from and where we will eventually get to in this class is a lot of graphing of straight lines and curved lines and solutions to where they fall within those lines. If we were to solve for these and get the y's by himself, it would wind up, it's not these numbers, but it would wind up in this type of form. Okay, we could get the y by itself by moving this over and dividing by 4, and then we'd have our rise and our run. So when we go, you don't need to write this. When we go to graph it, if I were to graph it, it crosses the y-axis at a certain spot, and then I do my rise and run, and I connect it. That would be one of the lines. And then when I go to do the other line, what we're looking for is where they cross at. That is the solution to the equation, because that's what they have in common. Okay, and that's where that is at. So that's why it has to work in both. Because it has to be where they cross at, not just them. Because otherwise you're just saying, oh yeah, it works in this equation, but it didn't fit in the other equation, then it's not a solution. So that's where that comes from.
And you just say no, you don't say it.
Yeah, just yes or no. Yes. Okay. Okay, almost done. One more after this. I'm glad you brought that up because I wrote that down to remind you guys of lines. But
I got you.
yeah, I know you did. I'd worry about who's behind you though.
Me too.
I don't know, he's just sitting there smiling. It's just kind of weird. Okay, so this one we're actually solving for. It's not a, is this a solution to the equation? Okay, so I'm not going to throw up the question and say that you could have done it this way. This one we're actually solving, okay? So there is a way to get rid of fractions so that you don't have to work with it. If you like fractions and you know all the rules on fractions, you can do that with this one, okay? But regardless, to combine like terms, I have to, on adding and subtracting, have to have common what? Denominators. And I don't, so I can't even work with fractions. So we're just going to get rid of fractions so we don't have to do that extra step. Okay, so what is my common denominator?
30.
30. Okay, so I'm just going to write that over here so that I go, that's where that 30 came from, was the common denominator. Okay, and we put it on the outside. So just like the other one, you can't just change one to get rid of one fraction. You have to change the whole equation. Okay, so what we're doing is distributing. So don't write this. I'm just showing you because a lot of us do this in your head. Don't write this next part. When I distribute, it means I'm multiplying. So really this is 30x over 6. So a shortcut to doing that is I know that can divide into there, right? So that's why we're doing this, is to get rid of the denominator, because then it doesn't make it a fraction anymore, okay? So what you're doing is this number needs to be able to go into that number that's on the outside, okay? Because that gets us to this. So 6 can go into 30 5 times. So it's really 5 that I'm distributing to whatever's left at the numerator. So that becomes 5x, which is what I would have got when I had 30x over 6. That simplifies 5x. Okay, so that same method again. 5 can go into 30. How many times? 6. So it's really 6 that I'm distributing to that numerator. So 6 times 4x. 24. Okay, now I don't forget about the last one. Just because it doesn't have a fraction doesn't mean I don't still distribute it. So I've got to go 30 times 29. 870. Okay, now I can combine my like terms. So 5x and 24x will be 9x. Okay, and my last step would be to divide by 29 to get rid of it. So x would be 30. And this one was that. It doesn't say is 30 a solution to the equation. This problem is actually solving the equation. Okay, so you have to find the solution. Okay, so it kind of goes back and forth between. Good?
That's the same answer I got.
What?
No way.
Okay, last one.
That's crazy. Thank you.
I must have done it wrong then. Okay, so that reads 6a equals 7, and then parentheses 7a minus, and then a bracket. 6a plus parentheses 8a minus 3 parentheses bracket parentheses plus 4. Okay, so some more order of operations, just a little more extensive than what we've been doing. So you just have to pay attention to parentheses and brackets because we have a lot of them. Okay, so innermost first. So we've got to do this part first. Okay, is there anything inside there that I can do? No. So now we work outside. There's no distribute to there. Okay, so I go to the next one. So really, my first step is going to be combining those two because those will be like terms. Okay, so I'm going to write what we have so far. So we have 6a equals 7, 7a minus bracket. Okay, so 6a and a positive 8a is
14.
okay. Okay, this comes down. Okay, I can drop this parentheses because there wasn't, and you will, that's why it's there. You will have some that will have negatives right there, where you'll have to change and distribute that A with a negative, but it doesn't on this one, so now I can drop it. But I still have that bracket. Okay, and then parentheses plus. Okay, we good to there? Okay, so just like this one, we would have started with the bracket first, but there's nothing inside the bracket we can simplify, so we go right outside of the bracket. Now this one has a negative where that first one didn't. Okay, so that means I need to distribute that negative to that bracket, which will change them to the opposite sign. Okay, so that needs to get distributed to both of those. Okay, so I'm just going to go ahead and write what our new thing is now. So 6a equals 7, parentheses, 7a is still there. I'm just distributing the negative, so it's a negative 14a. And then a negative times negative would be a positive 3. We're done with the bracket now. Just get that up. It's very easy to lose numbers on this one. And you'll have several of them on each of them. Okay, again, inside the bracket, is there anything inside, or the parentheses now, because we got rid of the bracket? Right, so we're going to combine that first. Okay, so again, I'm going to write what's still there, so I'm not losing track of things. Okay, so 7a minus 14a is going to be a negative 7a, okay, plus 3, and then the plus 4. Okay, I still have parentheses, but there's nothing inside the parentheses. So once it gets to that point, just like we did on the other ones, we go right outside. Okay, so there's nothing inside that I can simplify, so now I go right outside of it. Well, there's a number right there. So what does that mean when a number's right next to it? Distribute. Okay, so that means I have to distribute that to both of those numbers. And then I can drop that parentheses. So now I'm at 6a equals 7 times negative 7 would be negative 49a. Okay, and then 7 times 3, 21. And I can drop the parentheses now, okay, because I've already distributed.
And the answer is
Okay, so we're going to move the a's to one side. Okay, so I'm going to move this negative 49a over to the other side, so it'll change from a negative to a
Positive.
positive 49a. Okay, I'm just gonna cross this off. Okay, so 49A and 6A is gonna give me 55A. Okay, and then these two are already like terms on the one side they're supposed to be on, so that would be 25. Now I'm at my very, very last step, other than simplifying, would be to divide by what? 55, to get the A by itself, right? So when I divide here, it's the A by itself, but I gotta divide on the other side. Okay, so now reduce. What can go into both of them? 5. So 5 goes into there 5 times, and 5 goes into there 11. What? Okay, so again, a lot of you will be able to do that in your El Braino. Just don't lose track of positives and negatives or numbers, because then it just messes up the rest of the process. Okay. Okay, so that was the last one. Okay, so these you hand in when we what?
Lesson quiz.
Okay. Okay, so you're doing try it, and then we'll grade the try it hopefully before the end of class. If you finish the try it early, because there's only 16, you can start chipping away at the con. The con's on there. It's not due until next Tuesday midnight. So, Joyce, Bill, Alex. Okay. Yeah.
Hey, no.
Hey,
No.
no,
No.
no.
You just saying hi.
She was telling you hi. Okay, you might want to shake your head. Go like this. Like this. Shake your head.
That's what I was gonna tell you. And then, 20 minutes ago? No. No.
Yeah, it was really nice when they started doing it.
Yeah, I started doing it a long time ago. He kept moving. He kept falling on.
When he turned around, it was little loud.
Yeah.
Not 20 minutes ago. I know they were doing it 20 minutes ago.
For the police guy had a thing in your schools. Yeah. Thanks, man. I guess that. What's going on, man?
Oh. No, I was asking about that.
Cookies, yeah. That way. I mean, it's called out.